In this video, we're going through the lower block, which is primary 3 and 4, the modules of cycles. Topic is matter, and we're looking at some previous examination questions. Okay, this person has a clear plastic container filled with water. It has a hole on top of the container, so there's a hole on top of the container somewhere here. She pours out the water as shown below. When water is flowing out of the container, bubbles can be observed rising up to the surface of the water. Explain why. So whenever you see this word explain why, you always need to put the thing that you need to explain, so bubbles can be observed rising up to the surface of the water at the end. So bubbles rising to surface. So it's because this is the thing you need to explain. And then in the middle, the beginning is water flowing out of the container. So water flow out of container. All right. So this is the initial state and this is the final state. So your answer you need to give some scientific explanation to explain from this state to this state. Okay, why? And constantly ask yourself, so what? All right, so I'll show you how to do it. So the initial state is when water is flowing out of the container. So what happens when water is flowing out of the container? There will be a space, all right, at the top of the container, which was previously occupied by the water. All right, so there'll be when water flow out, there'll be a space. It creates a space at the top of the container. Then this space was previously occupied by the water, and air will. So what if there's a space, right? Yeah. So what if there's a space that's previously occupied by the water, right? What's the big deal? The big deal is the air will rush in to fill this space. All right, air will rush in to fill this space. And so what if air rushes in to fill this space? And therefore you will see bubbles rising to the surface, because that's the air rushing in to fill the space that was previously occupied by the water. So this is the space that I'm talking about. So in this question, you need to understand that air will escape and air will enter and air will escape as well. And when the water is flowing out, the air will rush in to take the space that was previously occupied by the water. All right. So this is an explain why question. So you need to write out the initial state, which is water is flowing out of the container. You need to write out the final state, which is basically what you're supposed to explain, which is bubbles rising to the surface. In between the initial and the final is your explanation. So you need to write down, so you need to constantly ask yourself, so what's going to happen when water flows out of the container? And then slowly figure it out yourself. Use your science knowledge to figure out, like, why does water flow out of the container will eventually lead to bubbles rising to the surface. All right, so I'll be using this, you'll be hearing me explain this many times throughout this topic, throughout other topics. Learn how to use it. Okay, so learn how to use it, learn how to use this initial state, final state, and the scientific explanation in the middle, and you will be able to get your marks for the 1 and 2 mark questions. In another experiment, Athiba released 2 objects X and Y, each from the same position, into a cylinder with 200 cubic centimeters of water as shown below. So object X goes down, object Y goes down. She recorded the time needed for each object to reach the bottom of the cylinder. All right, X took 10 seconds and Y took 4 seconds. All right, what does this tell us about the mass of object X compared to the mass of object Y? Okay, so everything else being equal, if you take longer to sink down, your mass is actually smaller or lesser. All right. So this one will have a smaller mass because it takes longer. If you are heavier, then you will drop down faster. And this one has a larger mass. So what does this tell us about the mass of object X as compared to mass of object Y? So mass of object X is smaller than the mass of object Y. All right. And the reason is because they didn't ask. The reason is because it takes longer to fall in the water. Alright, so the longer it takes, the lighter the mass. And the faster it takes, the heavier the mass. State the property of matter that is needed for the experiment to be carried out is that matter has what? Has mass. Alright. So there are two properties. The other property of matter is that it takes up space. Alright, so matter has mass and takes up space. So these are the two properties that you have to remember. Alright, and you'll be seeing this in the other questions. Okay, so there's a glass container, capacity of 500 cubic centimeters. So she filled a pump on the container. Each time she pumped in 100 cubic centimeters of air would enter the container. She pushed the pump 6 times. So they draw the line graph of the amount of air entering the container. Now, what is the thing about air? So air has no definite shape plus volume. Alright. So the thing is the shape. What does this no definite shape and volume actually means? So it means if I have a container over here and I pump in air. So let's say this container is 100 cubic centimeters. If I pump in 10 cubic centimeters of air, it will, because there's no definite volume, right? So it will occupy the entire 100 cubic centimeters. If I pump in 100, it will also occupy 100. If I pump in 1,000, it will also occupy just 100 cubic centimeters of air. So the key thing to remember this is that air will only occupy the available space. Alright, so the available space. And therefore, if I have a container, and I say that this container is 500 cubic centimeters, but then 100 cubic centimeters is water. Alright, what this means is that air will only be able to occupy the 400 cubic centimeters. Okay, it cannot occupy more than that, it cannot occupy less than that. Any amount of air you put inside will occupy this 400 cubic centimeters. Okay, so let's look at this question. So 100 cubic centimeters of air in this pump, so there's 100 cubic centimeters. I times 6 is actually equals to 600 cubic centimeters. But I told you, no matter how much you put inside, it will only fill up the available space. So air can only fill up the available space, alright, that is not taken up by water or any solids. So Mrs. Goh pushed the pump 6 times. Her student Jack and Jill drew a graph of the amount of air. So let's just draw the graph ourselves. So the graph should actually look like this. So this is volume in the glass container, and this is volume, okay, not volume, but actually the number of pumps. Alright, so there's 1 pump, 2 pump, 3 pump, 4 pump, 5 pump, 6 pumps. So at the first pump, how much, what is the volume of air going to be? Alright, at the very first pump, there's only 100, 200, so 3 pumps, 4 pumps, 5 pumps, 6 pumps. Like I said, air will take up all available space. So at the first pump, it will be at 500. Right at the first pump. Although there's only 100 cubic centimeters of air, it will take up all 500 of the capacity. And then the second pump, it will also be at 500, 500, 500, 500, 500. So it should be a straight line. All right, this is something you have to learn and you have to remember. Alright, air will only take up all available space, no matter whether there's more cubic centimeters or less cubic centimeters. So it will be a straight line graph of air. So let's take a look whose line is drawn correctly. So it's actually Jack. Alright, Jack is drawn correctly. So explain why. So it's because air has no definite volume. Alright, no definite volume means the volume can change. Means the volume can change to any kind of volume and will take up take up all available space, and therefore you get a straight line at 500 cubic centimeters, even if there is lesser or more volume of air pumped in. Alright, so this one is critical for you to understand. So Jack is the one that's correct, alright, because air has no definite volume. Actually, you can write and shape, might as well, right? Air has no definite volume and shape, and air will take up all the available space. So what if it takes up all the available space? Therefore, there is a straight line at 500 cm cube or cubic centimeters, even if there is lesser or more volume of air pumped in than 500 cubic centimeters. Okay, so that's how you answer this kind of question. You need to say no definite shape and volume, and will take up all the available space. Using the same set of apparatus, Mrs. Goh pumped in 50 cubic centimeters of water into the container. What is the volume now? So initially it was 500 cubic centimeters. Now there is 50 cubic centimeters of water. Alright, so like I said, air will take up all available space that they have. So this is the available space that it has, which is 500 minus 50, which is 450 cubic centimeters. So air will take up this 450. Whatever amount of air you pump in 10 cubic centimeters, it will take up all 450. You pump in 1,000, it will also take up 450. And that's because air has no definite shape and volume. Now, water has a definite volume, so you cannot change the volume of the water. It will always stay at 50 cubic centimeters, and that's why you need to minus off from the 500 to get the 450. Okay, so what will be the volume of air in a container now is actually 500 minus 50 equals to 450 cubic centimeters. Okay, Mrs. Goh continued to pump water. However, she could not fill the container completely with water. Explain why. So explain why cannot fill, right? So you just write here, cannot fill, all right, completely. And the initial state is continue to pump. So I just write here, continue to pump. So again, continue to pump, so what? All right, keep asking yourself, so what? And finally, cannot fill completely. So as you continue to pump water, the air is what? Air is a matter and takes up space. All right, air will take up the space. And because this is a 1-mark question, so you're expected to give 1 to 2 scientific explanations. So air takes up space, this is your 1 scientific explanation. Can you ask yourself, so what? So what if air takes up space? Is there anything else you know? Air has no definite shape and water has definite volume, blah blah blah. So I cannot think of anything else. So therefore, air takes up space, and therefore you cannot fill the container completely. Alright, so that's again your scientific explanation in the middle. If it's a 1-mark, 1 to 2 scientific explanations, the initial state, final state, and fill in the middle yourself. Study the flow chart carefully. Is it a matter? Yes. It's not a matter? No. Does it have a definite shape? Yes, definite shape means it's a solid. Alright. No definite shape. Yes, definite volume means it's a liquid. Alright, is it a matter? No, it's not a matter. Alright, so this one is your own analysis. You should be able to fill in these two things without the help of the MCQ answers below. So does it have a definite shape? You need to know, once it have a definite shape, then yes, it's a solid. If it has a definite volume, then it's a liquid. So let's take a look. C should be a liquid, so wind is not. Wind is a air. Saliva is a liquid. Spoon is not. B should be a solid, so needle is a solid. Fork is a solid. Spoon is a solid. Milk is a liquid. Is it a matter? Nope, not a matter. Noise is not a matter. Wind is a matter. Noise is not a matter. Saliva is a matter. Okay, so noise has no mass and does not take up space. So the answer is number 3. Shirley pressed a sponge in the tub of water as shown below. Bubbles were observed escaping from the sponge. Which one of the following statements explains the escaping bubbles? Okay, so even before we look at the answers, we know that this is a sponge, all right, and there's a lot of holes in the sponge, and there is air trapped in the sponge, and air takes up space. All right, always remember this: air is a matter, it takes up space, and it has mass. So now, if I reduce the volume, so the volume has reduced because I press it. So air takes up space, and there's not enough space for the air, so it will escape. All right, so the air will escape because there's not enough space. So that's your own analysis. You have to understand this. Sponge question, your teachers will love sponge questions, always come out. So learn how to do this. Okay, which one of the following statements explains the escaping bubbles? Air trapped in the sponge was released. Water trapped in the sponge was released. So air, let's look at water. Water trapped in the sponge was released. This doesn't explain air bubbles. This will, I don't know, it doesn't explain air bubbles, okay? Because water will not produce air bubbles. Air trapped in the sponge was compressed. No, it's not compressed. Like I said, you compress the sponge, the air will escape, all right, or release. Water absorbed in the sponge was compressed. No, you cannot compress water, first of all. And water, you cannot compress water. So this is not true because water has a definite volume, so you cannot compress water. So it's air trapped in the sponge was released. Okay, so this is the answer. I prefer the word escape, but they write release, that's fine. So it's number 1. Kelly compared 4 different objects A, B, C, D on balances shown below. Every time I see this kind of question, all right, it's very complicated. You'll surely forget which is heavier than who. Draw this line. This is my upward slope line. Put here heavy, put here light. Okay, have this line it will help you to organize your thoughts and prevent careless mistakes. So B and C, who is heavier? B is heavier than C, so put B here and put C here. D and A, who is heavier? D is heavier than A, so put D here and put A here. D and C, C is heavier than D, correct? C is heavier than D, so C is heavier than D, put D here. D is heavier than A, put A here. So yeah, that's it. Okay, so I try and do again for you in case you missed it, so I'll do it slower this time. Alright, so draw this line. This is my upward slope line. Put heavy, put light over here, so you know who is heavier than who. Now B and C, you know B is heavier than C because B is below, C is on top. So just put B and C. Alright, B and C, B is heavier than C. D and A, D is heavier than A. Now I don't see D and A over here, right? So it's okay lah. So D is heavier than A. Just put here D is heavier than A. Alright, because I cannot compare. Now D and C, C is heavier than D. C is heavier than D. So D must be here. C is heavier than D. And D is heavier than A. So D is heavier than A. So your line is like that. So B, C, D, A. So this is from light to heavy. So that's how you analyze this kind of questions. And then once you have this thing, then all this is very easy to do already. B has a smaller mass than D. Is that true? B is the heaviest, so it cannot be the smaller mass. Wrong. C has a smaller mass than A. C has a smaller mass, so C is heavier than A. Wrong. B has a greater mass than A. B has a greater mass than A. Correct. A has a greater mass than D. A has a greater mass than D. No, A is lighter than D, so wrong. So the answer is number 2. Alright, so for this kind of questions, super critical that you need to do this upward slope thingy. If you don't do it, and I'm sure if you have tried this kind of questions before and you never do, it gets very, very confusing. Who is heavier than who? Alright, and my brain cannot take it, so not to say yours. So my brain likes to do one step at a time, so I'll convert all this complicated looking diagram to a ranking system over here. All right, and then I will just rub this away, use correction tape and rub this away, and it's super clear to me, right? A is the lightest, B is the heaviest. All right, because I have this word light and heavy over here. So If you don't understand, just go through this part of the video again. Make sure you know how to come up with this upward slope line. Then label it light and heavy over here. Then, write it out and see which is lighter and heavier. This question always comes out, okay? Learn how to do this. Okay, so someone wanted to find the volume of M and a stopper. She first dropped M into a measuring cylinder with 30 cm. So initially there was 30 cubic centimeters of water. Then she tied a stopper to object M as shown below. What are the likely volumes of object M and the stopper? So M is M plus water. So M plus the water is actually 60 cubic centimeters. All right, over here, 60 cubic centimeters. So they told me the water is 30 cubic centimeters. So what is M? So M is actually 60 minus away the original equals to, so M is 30 cubic centimeters. Okay, so you take the original of the water, the new water minus the original, the new volume minus the original volume. All right, and that gives you the volume of M. Now, with what I told you, now this is the new item. New volume 70, original volume is 60. What is the volume of the stopper? So new volume minus original volume equals to 70 minus 60 equals to 10 cubic centimeters, and that is the volume of the stopper. Alright, so 1 kg brick, 1 kg cushion. Which of the following statement is true? So brick is, so both have the same mass. Must understand this, both have the same mass because they're both 1 kg. It's just same mass, a different volume. Alright, I'm going to introduce this word to you. It's called density. Density. It's not in your syllabus, so you don't have to learn it. But density basically means, right, a brick is more dense than a cushion. Dense means the amount of mass squeezed into a smaller volume. So iron, metal is very dense because a bit of it is very heavy, but air is not so dense because you need a lot of air, then you get the same amount of mass as a little bit of iron. Okay, so this question is actually about density, but it's not in your syllabus, so don't worry about this word. Let's look at the questions, the options. So both objects have the same mass. This is correct. They have the same mass because both is 1 kg. The cushion is lighter than a brick. That's not true because both is 1 kg. Both objects occupy the same amount of space. That's not true. This occupies a bigger volume than this. All right, the brick has a smaller volume than this. So the correct statement should be the cushion occupies a larger volume or a larger amount of space than the brick. The brick can be compressed while the cushion cannot. Actually, wrong. It's the other way around. The cushion can be compressed, but the brick cannot. So the answer is number 1. Okay, someone blew a deflated balloon in a bottle. After a while, he found it hard to inflate the balloon further, even though there was enough space in the bottle. Why is that so? Okay, so this question quite interesting. This is a bottle. So a bottle will have air inside, and air is a matter. It takes up space. All right, so air takes up space. So when you blow the air, this is new air and it comes in. But what happens is that this balloon will compress the air that is originally in the bottle. All right, and at certain point in time, you cannot compress it anymore because air takes up space and has mass, all right, and takes up space, so therefore you cannot compress it anymore. So the way, if you want to inflate this balloon to take up the entire bottle, you need to cut a hole at the back of the bottle so that the air can escape through this hole. The air in the bottle can escape through the hole, and then the air that you blow in can inflate the balloon to the entire bottle. Okay, so let's take a look at the answers. So, which one of the following why Tom was not able? The air in the bottle has a definite volume. No, air has no definite volume, but it takes up space. The air in the bottle has no definite shape. This is correct, but it doesn't explain why Tom was not able to inflate. All right. The air in the bottle cannot be compressed further. That's right. So this is wrong. It cannot be compressed further because it takes up space and it only can be compressed to a certain amount. The air in the bottle does not have a definite volume. This is also correct, but it does not explain why Tom cannot inflate. So the answer is number 3, because the air cannot be compressed any further than what it was compressed. Study the following classification chart. Some matter, pen, paper, coin, soil. So this is solid lah. Milk, air, oil, yogurt. So this is liquid plus gas. Based on the classification chart, what can we conclude about group X and group Y? So this has definite shape plus volume. Definite shape plus volume. This group has only the air has no definite shape and volume. Milk, oil, and yogurt has definite volume, no definite shape. Alright, so a lot of short forms here, but I hope you know what I'm talking about. Let's take a look. Group X has definite mass, but group Y does not have definite mass. That's not correct. They all have definite mass. Even air have definite mass if you give it a definite volume. All right. So if there's a certain amount of air, it will have that certain amount of mass. So group X has definite shape. This is correct. Okay, this is correct. This is correct. But group Y does not have definite shape. Okay, so this is correct. Both are correct. Group X has definite volume. This is also correct. But group Y does not have definite volume. So this is wrong because yogurt, oil, and milk have definite volume. Group X takes the shape of the container. That's wrong. Group Y does not take. That's wrong. Group X, which is solids, do not take the shape of the container. Group Y, that are liquids and gases, take the shape of the container. So the answer is number 2. Alright, so just to quickly explain again, a group Y does not have definite shape. So you have solids, you have liquids and air, so they all do not have definite shapes. And these are all solids, so they all have definite shapes. So therefore, the answer number 2 is correct.